Welcome to SRA 221. In this lecture video, we will be going over firewalls. By the end of this topic, you should be able to explain TCP/IP monitoring, describe what the firewall can and cannot do, define packet filtering technology, and compare it to stateful packet filtering technology. Additionally, we will define proxy and firewall technology, and finally, you should be able to identify the various firewall architectures. Now let's get started and take a look at TCP/IP, the purpose of the Internet. So what is the Internet? The Internet is the world's largest network of networks with a collection of computers that are interconnected, which make up a wide variety of computer networks. From supercomputers to personal computers, each computer on the Internet has every imaginable type of software applications. So how do all these computers talk to each other and work together? When computers communicate, an end-to-end communication from one party to the recipient party is connected through a set of routers. The routers forward messages sent from one end to another, according to data communication protocols. These protocols define how the message should be encoded, how it is sent, and what path to take. Transmission Control Protocol, TCP, and Internet Protocol, IP, is the basic communication protocol that each computer uses to talk with each other for data transmission. Anything that has TCP/IP capability can utilize the Internet. When transferring information on a network, TCP breaks the information into small pieces called packets, which are sent separately during transmission. TCP is a connection-oriented protocol which has the capabilities to guarantee the correct delivery of the data packets. Data can be lost in transmission, so TCP has to detect errors and lost data. TCP will continue to trigger a transmission until all of the data is completely received on the other end of the transmission. IP handles carrying the TCP packets from one computer to another based on a 4-byte destination address called IP address. Each computer, called the host, is uniquely identified by a specific IP address on the Internet. The IP address ensures that each packet gets to the right destination. There is a successor to the 4-byte IP address, which is known as IPv6, or Internet Protocol version 6. Space in the Internet is running out, thus creating the need for IPv6. IPv6 is the next generation of routing and offers many improvements over IPv4, including a virtually unlimited number of addresses. Now let's take a look at an example of how TCP/IP works. Consider here the sender Alice is staying at the Hilton Hotel in Boston, Massachusetts. She wants to send a message to Bob, who is staying at the Sheraton Hotel in Los Angeles, California. Alice writes her message in the envelope containing her message. She will indicate both where Bob is staying, address, as well as the room number. We can draw a parallel here. The what TCP/IP address information is placed in a TCP/IP message. The room address corresponds to the TCP port, which specifies which program should receive the packet. The IP address corresponds to the hotel address, which is the unique address associated with the host. Now that we have an understanding of the protocol, let's quickly discuss how TCP ports work. TCP ports are associated with the applications. Every application on a given host will be assigned a port number. For example, port 80 is the standard port used by HTTP to send and retrieve web pages. Most application-level protocols are associated with one or more port numbers in TCP/IP. In computer networking, a port is an endpoint of communication in an operating system. While the term is also used for hardware devices, in software it is a logical construct that identifies a specific process or type of service. A port is always associated with an IP address of a host and the protocol type of the communication, and thus completes the destination or origination address of a communications session. A port is identified for each address and protocol by a 16-bit number, commonly known as the port number. Specific port numbers are often used to identify specific services. Of the thousands of enumerated ports, 1,024 well-known port numbers are reserved by convention to identify specific types of a host. The protocols that primarily use ports are the transport layer protocols, such as Transmission Control Protocol, TCP, and the User Datagram Protocol, UDP, of the Internet Protocol Suite. You can see some of the commonly used ports here on the slide. To establish a connection, TCP uses a three-way handshake. Before a client attempts to connect with a server, the server must first bind to and listen at a port to open it up for connections. This is called a passive open. Once the passive open is established, a client may initiate an active open. To establish a connection, the three-way or three-step handshake occurs. SYN. The active open is performed by the client sending a SYN to the server. The client sets the segment's sequence number to a random value A. SYN-ACK. In response, the server replies with a SYN-ACK. The acknowledgement number is set to one more than the received sequence number, i.e. A+1, and the sequence number that the server chooses for the packet is another random number, B. ACK. Finally, the client sends an ACK back to the server. The sequence number is set to the received acknowledgement value, i.e. A+1, and the acknowledgement number is set to one more than the received sequence number, i.e. B+1. At this point, both the client and server have received an acknowledgement of the connection. Steps 1 and 2 establish the connection parameter, sequence number, for one direction, and it is acknowledged. Steps 2 and 3 establish the connection parameter, sequence number, for the other direction, and it is acknowledged. With these, a full duplex communication is established.